have to write the rule for the sequence. So describe the pattern, figure out what's going on, write the next term, and write the rule for the nth term. So if you look at A, I see it's going negative, positive, negative, positive. They call that an alternating sequence. Let's see. Alternating, let me make sure that shows up correctly. Sequence. Now, when you have that, you have two options. You have -1 to the n, or you have -1 to the n plus 1. So you're going to use -1 to the n if it started negative. Starts negative, and then goes positive, negative. And then you're going to use this n plus 1 if it starts positive. And again, this is only if it's alternating positive, negative. Otherwise, you don't need that part. So if you look kind of at the pattern, we know our next number would be negative. Now I look at the denominators, and each time it's multiplying by 3. So if I did 81 times 3, that would be 243. Now as far as writing a rule for that, we could say a sub n equals, now again, look up here. If it starts negative, we're going to say -1 to the n times, and then we look at what's going on here. I see the numerator is pretty consistent, so we're going to leave that as 1 over. And if I look at the denominators, again, it's multiplying by 3. So the first term is 1 over 3. So that's like 3 to the first power. Our second term is 1 over 9. That's 3 to the second power. 27 is 3 to the third power. That's also our term number. So we could say 1 over 3 to the n power, because again, n represents the term number. So that's probably the toughest one we have. Let's look at our term numbers here on B. Our first term is 2, our second term is 6, our third term is 12, and then our fourth term is 20. That's what they've given us. So I could see that 1 times 2 is 2, but 2 times 2 is 4, not 6. That's like 2 times 3. 3 times 4. 4 times 5. So every time you're taking the term number and you're multiplying it by the next larger number. So the way we're going to write that rule is a sub n equals n, our term number, and then we're going to write times one number larger than that. So the way we're going to represent one number larger would just be our term plus 1. So n times n plus 1. Now if it said write the next term, our fifth term would be 5 times 5 plus 1. 5 times 6 would give us 30. So I have 2 for you to try here, I believe. No, I have 4 for you to try. So try to get the formulas for these, and I will write kind of what we got going here. And then you can check. Okay, first term, second, third, fourth. Okay, a sub n equals, it's essentially 1 divided by our term number. That's it. Let's see. 1, 2, 3, 4. If you look at the pattern, each one is our term number times 3, right? 3 times 1 is 3, 3 times 2 is 6. So we'll say a sub n equals 3 times our term number, 3 times n. Those were not too bad. Okay. Oh, we've got an alternator. Uh-oh. Alternator. A sub n equals, and it's starting negative, so we'll say -1 to the n. So this is our first term, here's our second term, here's our third term, here's our fourth term. Now if I'm looking at the second term, if I did -1 to the second power, that's +1. And then, so we're going to need to also multiply that by our actual term. Because +1 times 2 would give us that 2. Oh, that's supposed to be n.